When wiring an electric range, determining the correct circuit size is essential for safe and reliable operation. The appliance's nameplate provides critical information about its power requirements. Let's break down how to calculate the appropriate circuit size based on the nameplate rating. The nameplate rating specifies the maximum power the range can draw, typically expressed in kilowatts. To determine the required amperage, we use the formula power equals voltage times current. For example, if a range has a nameplate rating of 14.4 kilowatts and is designed to operate at 240 volts, the calculation is as follows. Firstly, convert kilowatts to watts. 14.4 kilowatts equals 14,400 watts. Secondly, apply the formula current equals power divided by voltage. Therefore, current equals 14,400 watts divided by 240 volts, which equals 60 amps. This calculation indicates that a minimum 60 amp circuit is required to safely operate the range at its full capacity. It's crucial to understand that the instructions provided with the appliance, while potentially helpful, should not override the nameplate rating. The nameplate reflects the actual power demands of the range, and it must be the guiding factor in determining the circuit size. If the instructions suggest a smaller circuit size than what the nameplate calculation indicates, prioritizing the nameplate is paramount. Installing a circuit smaller than required can lead to several issues. For instance, during high power usage, such as when multiple burners and the oven are operating simultaneously, the circuit breaker is likely to trip frequently. This is because the range will be drawing more current than the circuit is designed to handle, leading to an overload. Moreover, consistently overloading a circuit can create a fire hazard. The excessive heat generated by the overloaded wires can damage the insulation, potentially causing a short circuit and igniting nearby materials. Therefore, adhering to the nameplate rating and installing the appropriate circuit size is not just about ensuring proper operation, it's also about preventing electrical hazards. When selecting a circuit breaker for the range, it's important to choose one that matches the calculated amperage. In this case, a 60 amp circuit breaker would be appropriate. The breaker's purpose is to protect the circuit from overcurrents, so it must be sized correctly to trip before the wires overheat and cause damage. Additionally, the wiring used for the circuit must be appropriately sized to handle the anticipated current. Electrical codes, such as the National Electrical Code, specify the minimum wire gauge required for different amperage ratings. It's essential to consult these codes to ensure that the wiring is adequate for the range's power demands. Using undersized wiring can lead to overheating and potentially cause a fire. Beyond the circuit breaker and wiring, the receptacle, also known as the outlet, that the range plugs into must also be rated for the appropriate amperage. A 60 amp range requires a receptacle specifically designed to handle that level of current. Using a lower rated receptacle can create a point of failure and potentially lead to overheating or arcing. Furthermore, the installation of the range circuit must comply with all applicable electrical codes and regulations. This includes proper grounding, bonding, and protection against physical damage. It's always recommended to consult with a qualified electrician to ensure that the installation is done safely and correctly. In summary, determining the correct circuit size for an electric range involves calculating the amperage based on the nameplate rating, selecting an appropriately sized circuit breaker and wiring, and ensuring compliance with all applicable electrical codes. Prioritizing the nameplate rating over the instructions is crucial for safe and reliable operation. By following these guidelines, you can ensure that the range operates as intended and that the electrical system is protected from overloads and potential hazards. Consider this detailed breakdown. Firstly, begin by examining the appliance nameplate. The nameplate is a small metal or plastic label usually found on the back or underside of the appliance. It contains essential information about the appliance's electrical specifications, including the voltage, wattage, and amperage. The wattage rating, expressed in kilowatts, is the key to determining the required circuit size. Secondly, calculate the amperage. Use the formula amps equals watts divided by volts to calculate the amperage. Ensure you are using the correct voltage for the circuit, typically 240 volts for a range. For example, a 14.4 kilowatt range operating at 240 volts would require 60 amps. Thirdly, verify the manufacturer's instructions. Always consult the installation instructions that come with the appliance. While the nameplate rating is the primary factor, the instructions may provide additional guidance or recommendations. However, if there is a discrepancy between the nameplate rating and the instructions, always prioritize the nameplate rating. Fourthly, select the appropriate circuit breaker. Choose a circuit breaker that matches the calculated amperage. In this case, a 60 amp circuit breaker would be suitable. The circuit breaker protects the circuit from overloads and short circuits. Fifthly, choose the correct wire gauge. Select the appropriate wire gauge based on the amperage and the length of the circuit. Electrical codes, such as the National Electrical Code, specify the minimum wire gauge required for different amperage ratings. Using undersized wiring can lead to overheating and potential fire hazards. Sixthly, install a dedicated circuit. Install a dedicated circuit for the range. This means that the range should have its own circuit breaker and wiring that is not shared with any other appliances or devices. Dedicated circuits help prevent overloads and ensure that the range receives the necessary power. Seventhly, ensure proper grounding. Ensure that the range is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps protect against electric shock. Eighthly, inspect the wiring connections. Carefully inspect all wiring connections to ensure that they are tight and secure. Loose connections can cause overheating and potential fire hazards. Ninthly, test the circuit. After completing the installation, test the circuit to ensure that it is functioning properly. Use a multimeter to verify the voltage and amperage. Tenthly, consult a qualified electrician. If you are unsure about any aspect of the installation, consult a qualified electrician. A qualified electrician can ensure that the installation is done safely and correctly. Now let's delve into the National Electrical Code requirements for range installations. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations in the United States. It's crucial to adhere to the NEC to ensure the safety and compliance of the range installation. The NEC specifies the minimum wire size, overcurrent protection, and grounding requirements for range circuits. Table 310.15 B16 of the NEC provides the allowable ampacities of insulated conductors rated up to 2000 volts 60 degrees Celsius through 90 degrees Celsius in free air. This table can be used to determine the appropriate wire size for the range circuit based on the calculated amperage. For example, if the range requires 60 amps, the table would indicate the minimum wire size required to handle that current. The NEC also requires that range circuits be protected by an overcurrent device, such as a circuit breaker. The overcurrent device must be sized to protect the wiring from overloads and short circuits. The NEC specifies the maximum overcurrent protection allowed for different wire sizes. Additionally, the NEC requires that the range be properly grounded. Grounding provides a path for fault current to flow back to the source, which helps protect against electric shock. The NEC specifies the methods for grounding appliances and equipment. It's essential to consult the latest edition of the NEC to ensure that the range installation complies with all applicable requirements. Failure to comply with the NEC can result in fines, penalties, and potential safety hazards. Moreover, it's important to understand the different types of range circuits. There are typically two types of range circuits: 120/240 volt circuits and 120/208 volt circuits. The voltage of the circuit depends on the electrical system in the building. 120/240 volt circuits are commonly found in single-family homes, while 120/208 volt circuits are more common in apartment buildings and commercial buildings. It's crucial to identify the correct voltage for the circuit before installing the range. Using the wrong voltage can damage the appliance and create a safety hazard. Furthermore, it's important to consider the demand factors for range circuits. The NEC allows for demand factors to be applied to range circuits. Demand factors are used to reduce the calculated load for the circuit based on the assumption that not all of the range's elements will be operating at the same time. The NEC provides tables that specify the demand factors for different types of ranges and cooking appliances. Applying demand factors can reduce the required wire size and overcurrent protection for the circuit. However, it's important to carefully consider the demand factors and ensure that they are appropriate for the specific installation. In addition to the NEC, there may be local electrical codes and regulations that apply to the range installation. It's essential to consult with the local authorities to determine if there are any additional requirements. Local codes may have more stringent requirements than the NEC, or they may address specific issues that are unique to the area. By understanding the NEC requirements, the different types of range circuits, and the demand factors, you can ensure that the range installation is safe, compliant, and efficient. Remember, safety should always be the top priority when working with electricity. If you are unsure about any aspect of the installation, consult a qualified electrician. Let's elaborate on the importance of proper grounding in range installations. Grounding is a critical safety measure that provides a path for fault current to flow back to the source, which helps protect against electric shock. When a fault occurs in an appliance, such as a short circuit, the metal parts of the appliance can become energized. If a person touches the energized metal parts, they can receive a dangerous electric shock. Grounding provides a low impedance path for the fault current to flow back to the source, which causes the circuit breaker to trip and to energize the circuit. This helps prevent electric shock. The NEC specifies the methods for grounding appliances and equipment. Typically, appliances are grounded by connecting a grounding conductor, such as a green or bare copper wire, from the appliance to the grounding system of the building. The grounding system is connected to the earth, which provides a reference point for the electrical system. There are several different methods for grounding appliances, including grounding through the receptacle, grounding through a separate grounding electrode, and grounding through the metal conduit. The appropriate method depends on the specific installation and the requirements of the NEC. It's essential to ensure that the grounding connection is secure and that the grounding conductor is properly sized. A loose or undersized grounding conductor can compromise the effectiveness of the grounding system. Moreover, it's important to test the grounding system to ensure that it is functioning properly. A ground impedance tester can be used to measure the impedance of the grounding path. A low impedance reading indicates that the grounding system is effective. In addition to grounding, bonding is another important safety measure that helps to equalize the voltage potential between different metal parts of the electrical system. Bonding involves connecting the metal parts of the electrical system together, such as the metal conduit, the metal enclosures, and the metal parts of the appliances. This helps to prevent voltage differences from developing between the different metal parts, which can reduce the risk of electric shock. The NEC specifies the requirements for bonding electrical systems. It's essential to follow the NEC guidelines to ensure that the bonding is done correctly. By understanding the importance of grounding and bonding, you can help to protect yourself and others from electric shock. Remember, safety should always be the top priority when working with electricity. If you are unsure about any aspect of the installation, consult a qualified electrician. We should now discuss common mistakes to avoid when wiring an electric range. Wiring an electric range can be a complex task, and it's easy to make mistakes if you are not careful. Here are some common mistakes to avoid. Firstly, using the wrong wire size. Using undersized wiring is a common mistake that can lead to overheating and potential fire hazards. It's essential to select the appropriate wire gauge based on the amperage and the length of the circuit. Consult the NEC to determine the minimum wire size required for the range circuit. Secondly, failing to properly ground the range. Failing to properly ground the range is a serious safety hazard that can increase the risk of electric shock. Ensure that the range is properly grounded by connecting a grounding conductor from the appliance to the grounding system of the building. Thirdly, using the wrong type of receptacle. Using the wrong type of receptacle can create a point of failure and potentially lead to overheating or arcing. Ensure that you are using a receptacle that is specifically designed for use with electric ranges. Fourthly, making loose wiring connections. Loose wiring connections can cause overheating and potential fire hazards. Carefully inspect all wiring connections to ensure that they are tight and secure. Fifthly, ignoring the manufacturer's instructions. Ignoring the manufacturer's instructions can lead to improper installation and potential safety hazards. Always consult the installation instructions that come with the appliance and follow them carefully. Sixthly, overloading the circuit. Overloading the circuit can cause the circuit breaker to trip and potentially damage the wiring. Ensure that the range circuit is not overloaded by other appliances or devices. Seventhly, working on a live circuit. Working on a live circuit is extremely dangerous and can result in serious injury or death. Always energize the circuit before working on it. Eighthly, failing to inspect the wiring before energizing the circuit. Failing to inspect the wiring before energizing the circuit can lead to undetected problems and potential safety hazards. Carefully inspect all wiring connections and ensure that everything is properly installed before energizing the circuit. Ninthly, not testing the circuit after installation. Not testing the circuit after installation can lead to undetected problems and potential safety hazards. Test the circuit to ensure that it is functioning properly. Tenthly, not consulting a qualified electrician. Not consulting a qualified electrician can lead to improper installation and potential safety hazards. If you are unsure about any aspect of the installation, consult a qualified electrician. By avoiding these common mistakes, you can help to ensure that the range installation is safe, compliant, and efficient. Remember, safety should always be the top priority when working with electricity. If you are not comfortable working with electricity, consult a qualified electrician. This is another important consideration when dealing with ranges. We'll delve into troubleshooting common range problems. Electric ranges can experience a variety of problems ranging from simple issues to more complex malfunctions. Troubleshooting these problems effectively requires a systematic approach and a basic understanding of how the range operates. Firstly, no power to the range. If the range is not receiving power, the first step is to check the circuit breaker. Ensure that the breaker is not tripped. If it is, reset it. If the breaker trips repeatedly, there may be an overload or a short circuit in the range or the circuit wiring. If the breaker is not tripped, check the power cord and the receptacle. Ensure that the power cord is properly plugged into the receptacle and that the receptacle is functioning properly. Use a multimeter to verify that the receptacle is receiving the correct voltage. Secondly, burner not heating. If one or more of the burners are not heating, the problem may be with the burner element, the burner receptacle, or the control switch. Use a multimeter to test the burner element for continuity. If the element has no continuity, it is likely burned out and needs to be replaced. Check the burner receptacle for loose or corroded connections. Clean or replace the receptacle as needed. Test the control switch to ensure that it is functioning properly. If the switch is faulty, it needs to be replaced. Thirdly, oven not heating. If the oven is not heating, the problem may be with the heating element, the oven thermostat, or the control panel. Use a multimeter to test the heating element for continuity. If the element has no continuity, it is likely burned out and needs to be replaced. Check the oven thermostat to ensure that it is functioning properly. If the thermostat is faulty, it needs to be replaced. Test the control panel to ensure that it is sending the correct signals to the heating element and the thermostat. If the control panel is faulty, it needs to be repaired or replaced. Fourthly, uneven cooking. Uneven cooking can be caused by a variety of factors, including improper oven temperature, incorrect rack placement, or a faulty heating element. Verify the oven temperature using an oven thermometer. If the oven temperature is inaccurate, adjust the thermostat accordingly. Ensure that the racks are properly placed in the oven. Avoid overcrowding the oven, as this can restrict airflow and lead to uneven cooking. Inspect the heating element for damage or wear. If the element is damaged, it needs to be replaced. Fifthly, error codes. Many modern ranges are equipped with electronic control panels that display error codes when a problem is detected. Consult the owner's manual to determine the meaning of the error code and the appropriate troubleshooting steps. Some common error codes indicate problems with the temperature sensor, the door lock, or the control panel. Sixthly, self-cleaning problems. Self-cleaning problems can be caused by a variety of factors, including a faulty door lock, a malfunctioning temperature sensor, or a problem with the control panel. Ensure that the oven door is properly closed and locked before initiating the self-cleaning cycle. Check the door lock mechanism to ensure that it is functioning properly. If the door lock is faulty, it needs to be replaced. Test the temperature sensor to ensure that it is functioning properly. If the temperature sensor is faulty, it needs to be replaced. Test the control panel to ensure that it is sending the correct signals to the door lock and the temperature sensor. If the control panel is faulty, it needs to be repaired or replaced. Seventhly, strange noises. Strange noises, such as buzzing, clicking, or humming, can indicate a variety of problems, including loose wiring, a faulty component, or a problem with the motor. Inspect the wiring connections to ensure that they are tight and secure. Check the components, such as the heating elements, the thermostat, and the control panel, for signs of damage or wear. If you suspect a problem with the motor, consult a qualified appliance repair technician. Eighthly, smoke or burning smell. Smoke or burning smell can indicate a serious problem, such as a short circuit, overheating wiring, or a food spill. Immediately turn off the range and disconnect it from the power source. Inspect the wiring for signs of damage or overheating. Check for food spills or debris in the oven or on the burners. If you suspect a short circuit or overheating wiring, consult a qualified electrician. Ninthly, control panel problems. Control panel problems can range from unresponsive buttons to a completely malfunctioning display. Check the power supply to the control panel to ensure that it is receiving the correct voltage. Inspect the wiring connections to the control panel to ensure that they are tight and secure. If the control panel is unresponsive, try resetting it by turning off the range and disconnecting it from the power source for a few minutes. If the control panel is still not functioning properly, it may need to be repaired or replaced. Tenthly, door problems. Door problems, such as a door that won't close properly or a door that won't lock, can affect the oven's performance and safety. Check the door hinges to ensure that they are properly aligned and lubricated. Inspect the door seal to ensure that it is intact and providing a tight seal. If the door won't lock, check the door lock mechanism to ensure that it is functioning properly. If the door is damaged or not functioning properly, it may need to be repaired or replaced. By understanding these common range problems and troubleshooting steps, you can often diagnose and resolve issues quickly and effectively. However, it's important to remember that working with electricity can be dangerous. If you are not comfortable working with electricity, consult a qualified appliance repair technician. Let's pivot to safety precautions for working with electric ranges. Working with electric ranges can be dangerous if proper safety precautions are not followed. Here are some essential safety measures to keep in mind. Firstly, always disconnect power. Always disconnect the power to the range before performing any repairs or maintenance. This can be done by turning off the circuit breaker that supplies power to the range. Secondly, use proper tools. Use insulated tools when working with electrical components. This will help protect you from electric shock. Thirdly, wear safety glasses. Wear safety glasses to protect your eyes from debris or sparks. Fourthly, avoid water. Avoid working with electrical components in wet or damp conditions. Water can conduct electricity and increase the risk of electric shock. Fifthly, be aware of surroundings. Be aware of your surroundings and avoid distractions while working on the range. Sixthly, follow instructions. Follow the manufacturer's instructions carefully when performing any repairs or maintenance. Seventhly, inspect wiring. Inspect the wiring for signs of damage or wear. Replace any damaged or worn wiring. Eighthly, test grounding. Test the grounding system to ensure that it is functioning properly. Ninthly, don't overload circuits. Do not overload the circuit that supplies power to the range. Tenthly, consult professionals. Consult a qualified electrician or appliance repair technician if you are not comfortable performing the repairs yourself. And now to electrical codes and regulations. Electrical codes and regulations are in place to ensure the safety of electrical installations. It's important to be familiar with the relevant codes and regulations when working with electric ranges. The National Electrical Code, or NEC, is a widely adopted set of standards for electrical installations in the United States. The NEC provides guidelines for wiring, grounding, and overcurrent protection for electric ranges. Local electrical codes may also apply. These codes may be more stringent than the NEC, or they may address specific issues that are unique to the area. It's important to consult with the local authorities to determine if there are any additional requirements. Failure to comply with electrical codes and regulations can result in fines, penalties, and potential safety hazards. By following these safety precautions and adhering to electrical codes and regulations, you can help to ensure that the range installation is safe and compliant. Remember, safety should always be the top priority when working with electricity. If you are unsure about any aspect of the installation, consult a qualified electrician.